Now let's take a look at the concepts of solving proportions in algebra. Well, let's go and look at this problem. Here's what I mean by that. Let's say I have something like 5 over 2x plus 3 equal to, let's say, 10 over x minus 3. Let's say I have one fraction on each side of the equation. Okay. Well, we've seen this before somewhere, all right? Except we saw with the in Math 30 with the variable term being on top instead of the bottom, all right? But but we've seen this actually. When you have one fraction equal to another fraction, you have what's called a proportion. And this is a proportion. And if you remember a proportion, right? If I have A over B equal to C over D, for example, then what's the equation I come up with? Well, with any proportion, we can cross multiply. In other words, their cross products will be equal to each other. In other words, A times D will be equal to what? B times C. Okay, so keep this concept in mind for what? Proportions. All right? So how do I go about solving this? Well, then I'm going to cross multiply. So again, we can only do this if we have what? One fraction on the left side, one fraction on the right side. If I have two fractions, I can't do this. Then it's not, because it's not a proportion then. This is a proportion. One fraction here, proportion. All right? Let's cross multiply then. So let's take 5 times x minus 3. So 5 times x minus 3. So these types of problems on the homework are very easy to solve because you just take the cross products, right? And then that should be equal to what? 10 times 2x plus 3. All right? So 10 times 2x plus 3. Can we see that? Taking the cross products, setting them equal to each other. All right? Let's quickly solve this then. So it's like a nice simple equation to solve. 5 times x is 5x. All right? 5 times negative 3 is negative 15, equal to 10 times 2x is 20x, I meant to say. And 10 times 3 is going to be 30. Okay, not too bad at all. All right? Let's get x on the right, numbers on the left, if you don't mind. Let me subtract 5x on both sides then to get the x's on the right side. All right? And let me combine a couple of steps, if you don't mind. Let me get the numbers. So x is on the right, what numbers on the left? So let me subtract 30 on both sides, if you don't mind, because I'll get rid of this 30 here. So I'll get numbers on the left. So this is what? Negative what? 45 equal to what? 15x. Make sure we're sharp on solving these basic equations. Review Chapter 3, Section 3.2 in particular if you need some more practice on that. All right? Divide both sides by 15. Okay? So x is equal to what? X is equal to what? Negative 3. All right? But once again, I need to check, is this a valid answer? Let's check the what denominators, right? 2 times negative 3 plus 3. Okay, that's not going to be 0, so that's fine. How about, again, x is negative 3. Negative 3 minus 3, that's negative 6. So we're good on that too, okay? Okay, now what if x was positive 3? Well, then that's no good because 3 minus 3 is what? 0. But x is negative 3, that's okay because negative 3, if I plug it in for x, minus 3 is going to be what? Negative 6. That's perfectly fine. So therefore, this solution is a valid solution here. So again, always check if your solutions are valid or not just by eyeballing it. You don't have to actually plug it in, just eyeball it, right? In other words, just look at the denominators, right? And think of this number being plugged in for x. Will it make the either denominator 0? In this case, it does not. So therefore, this is a valid solution. Okay? Again, for proportions, and how do I know when I have a proportion? When I have one fraction on each side of the equation, that's when I know I have a proportion. And how do I solve that? Cross multiply. The cross products will be equal to each other. All right? Let's go ahead and try another one here. Let's try this one here. All right? Let's take a look at 2x over 7 equal to x minus 2 over 14. All right? No big deal there. Okay? Actually, you know what? Let's go and scratch this problem. No, let me not. You can solve this. Just cross multiplying. But let me scratch it. Let me give you another one instead. Let's look at this one. Let's look at x. Let's look at x over. Let's make it x over 32, if you don't mind, equal to 2 over x. All right, let's go and look at this one instead. All right. So let's solve this one instead. Sorry about that. Okay. So again, cross multiply. I get one fraction on each side. Cross multiply. All right. So let's take the cross product here. X times x is what? X squared And then 32 times 2 is what? 64. Can we see that? 32 times 2, 64. All right, again, how do I solve this? Well, it's a square term, so I should solve by factoring. So, we haven't talked about taking the square root of both sides yet. We'll get into that in a future chapter, all right? But right now, let's go, that's chapter 11, actually. So for right now, let's go ahead and solve by factoring. That means what? Make one side 0. Let's subtract 64 on both sides here. Okay, running out of space here, that's okay. So x squared minus 64 equal to what? 0. All right? So factor it. That's the difference of two squares, right? X plus 8, x what? Minus 8 equal to 0. Okay? So right now, if I set each factor to 0, what do I get? Well, imagine setting x plus 8 to 0. Then I would subtract 8 from both sides. I get what? Negative 8. All right? Imagine setting x minus 8 to 0. I would add 8 to both sides, and I would get what? Positive 8. And are both of these valid? Yeah, because it's not going to make the bottom 0. So we're good to go. And in fact, look, you can check it very easily here. Let's check positive 8. What is 8 over 32? Well, isn't that one quarter? Isn't 8 over 32 reduced to 1/4? Well, what is 2 over 8? That's also 1/4. So this answer is valid. Likewise for negative 8. So these are valid solutions here. Okay, so my solution again, in solving proportions by cross multiplying. In this case, I have to solve by factoring as well. And I get my two solutions here, negative 8, positive 8. Okay, so make sure we see that in this problem. Okay, all right. Let's go ahead and look at a couple of application problems for proportions, if you will. Right? Let's look at what's a word problem involving proportions. How can I use proportions to solve word problems? Here, let me go clear off the screen. Let me give you a sample problem here. All right. Let me say suppose a 5 feet or a 5 foot person, someone who's 5 feet tall, all right. Suppose a 5 foot person, 5 foot person makes a 2 foot shadow. Okay, so we can measure the person's shadow out in the sun. All right. And let me say that if the shadow of a flagpole is, let's say the flagpole shadow is, say, 9 feet. All right? Let's say the flagpole shadow is 9 feet. Then let's find the height of the flagpole. Let's think about this now. Okay, this is a proportions problem here, right? So we're told that, okay, someone who's 5 feet tall, their shadow, this person makes a 2 feet shadow, all right? But now obviously I can't measure a flagpole because it's too tall, it's too high, right? But I can measure its shadow though. What if the shadow is 9 feet? So what is the height of this flagpole? Well, let's match it up. So 5 feet in height makes a 2 feet shadow, right? So we can say 5 feet in height, all right, makes a 2 feet shadow. All right, we want to know, okay, how much height, so question mark on the height, how much height will make a 9 feet shadow? Because the flagpole is how high, right? It makes a 9 feet shadow, 9 foot shadow. All right, so how do I work it out? Well, what's this question mark here? Well, that's going to be x. Can we see that? Let's introduce a variable x. So we're saying 5 feet in height to 2 feet of shadow is the same as x feet in height to 9 feet of shadow. All right. So how do I set up the proportion then? Well, look at my arrows. Right. Height is to shadow as height is to shadow. That's how we'll set it up. In other words, we're saying this. We're saying 5 over 2 height is to shadow is equal to x over 9 height is to shadow. Can we see the logic here? All right, again, height is to shadow, 5 over 2, as height is to shadow, x over 9. There it is, all right? And this is a proportion we can solve very quickly. Cross multiply here, so we get 2x equal to 5 times 9, which is what? 45. So dividing both sides by 2, we get, sorry about that, we get the answer of what? 22.5. You can punch in the calculator. Or 22 and a half what? feet. So we estimate the flagpole based on the shadow to be what, 22.5 feet high, all right, in height. All right, can we see that? So again, we can use proportions here to find the height of objects that we can't measure. Okay, so we see the logic here. Okay, let's try another one. Let's look at investment problem. Yeah, we've done these problems before actually from Math 30, so it's actually not too bad here. All right, let's look at this one here. Let me say this. Suppose a $1,200 investment. Okay, so if I put in $1,200 into some kind of account investment, yields $96 in dividends. Okay, this is basically the interest that I'm going to get in dividends. All right. Question is how much additional? How much? Here's the key word: additional. Okay, how much additional investment is needed to earn, let's say, $128 in dividends. Okay, $120. Let me say dividends. All right. So suppose it. So if I put in $1,200, that'll give me $96. All right, in dividends. Basically interest here, right? How much additional investment do I need if I want to make $128 dividends? All right. Now the key word is the word additional. That means what? I'm not asking for how much total do I need to make 128. I'm asking for how much more do I need in addition to the what? To the 1,200 I've already put in. How much more do I need to put in? In other words, how much more do I need to add to this account to get me up to 128 dividends? All right. So let's look at the setup then. So again, $1,200 matches with what? $96 dividends. Okay. So, oops, sorry about that. Let me get my sketch pad right. Okay. So again, $1,200 investment equals what? $96 dividends. All right. Matches that. Right. So I want to know how much additional money do I need to put into this 1,200? How much do I need to add to this 1,200? So it's not going to be X. It's going to be what? 1,200 plus X. So X is my what? X is my additional investment. Okay. X is my additional investment. So 1,200 plus X will give me what? 128 dividends. Okay. So this is our setup. Can we see that? All right. So again, 1,200 will give me $96 dividends. How much additional money do I need on top of the 1,200 to get to 128? Well, make that X. So 1,200 plus X will get me to 128. All right, can we see that? Let's go and set it up then. So again, investment to dividends as investment to dividends. So let's go and do that. So 1,200 over 96, all right, equal to investment to dividends equal to what? Investment to dividends. So 1,200 plus X over what? 128. Okay, hopefully we see this proportion set up here. All right, can we see that? Now, let's look at this fraction, 1,200 over 96. I can reduce this fraction if I use my calculator. Remember that this fraction key here in your calculator, A, B/C. If you can work this feature, if you have this feature in your calculator, you can use that to reduce this fraction, which I have. I'm going to do that. So 1,200 over 96. All right, that gives me 25 over 2. So this reduces to 25 halves on my calculator. Now, do I need to reduce this fraction to solve this proportion? No, I don't, but reducing it shrinks my numbers. It makes it easier for me to work with. All right, so I'm going to do that since I have this feature on my calculator. All right, so 1,200 plus X over 128. Don't cancel the 1,200 and the 128 because the 1,200 is being lumped together with the X, right? 1,200 plus X, so you cannot simply cancel that. If I have 1,200 times X, then I can cancel that. I could reduce this fraction here as well. But here I cannot do that. All right, so keep it as 1,200 plus X. All right, let's go and cross multiply. So to solve proportion, we cross multiply. We set them equal to each other. 2 times 1,200 plus X, so 2 times 1,200 times 1,200 plus X equal to 25 times 128. Let me punch that into the calculator. 25 times 128. 3,200. Okay, just punch it in the calculator. No big deal. 2 times 1,200, 2,400. Let's quickly solve this equation. 2 times X, 2X, equal to 3,200. All right? Subtracting 2,400 on each side. running out of space here, so bear with me. So I get 2x is equal to what? 800. All right? And dividing both sides by 2, what's x going to be? $400. Okay, so $400. That means what? I need $400 of additional money to add to this 1,200 to get me up to 128 dividends. Can we see that? So $400 of additional, additional investment. Okay, to get me up to this dividends which I want. All right. Now, so that means what? That means what's the total amount that will give me 128? Well, then the total amount will give me what? 1,200 plus 400 is what? 1,600. So if you simply put x here instead of 1,200 plus x when you solve this problem, you're going to get 1,600. But again, we're not asking for the total to give you 128. We're asking for how much additional you have to put into this 1,200 to get to 128. So the answer should be what? $400. But if you just put x here and you got 1,600, no big deal. You just take the difference between that and 1,200, and you still get $400 as your answer of additional investment that you need to get to 128. Okay, so again, the solution here is going to be $400 of additional investment. All right, so that's what our solution will be for this problem. Again, we've seen these problems before, actually from Math 30, so recall how to set them up using proportions here, and then obviously cross-multiply to solve them, and use the fraction key to help you reduce fractions here. That's very useful, I think, on the calculator. All right?
All right, now let's take a look at the concepts of variation. Variation describes how two or more variables vary with each other. In other words, as one goes up, what happens to the other? Does it go up or does it go down? Well, let's look at these two types of variation on the homework. So two types, and we can actually combine these two types into a problem as well. Two types of variation. All right, the first type will be called direct variation. First type is called direct variation. And as you might expect, direct variation describes two variables that move in the same direction. That means as one goes up, so does the other. As one goes down, so does the other. Now, what phrases might you see on the homework regarding these types of application problems? Well, you may see something like this. You may see something like y varies directly as x. All right? So you might see something like this. Y varies directly as x. That means direct variation. As y goes up, x goes up. As x goes up, y goes up. As x goes down, y goes down, and so on. All right. Now you may also see this phrase. You may see that it may say something like y is directly proportional. Is directly proportional to x. Okay, so y is directly proportional to x. Again, that means the same thing, right? As one goes up, so does the other. Okay. All right. Now, what is the equation to describe direct variation? Well, the equation is very simple. When you see phrases like these, you want to think of the equation of y equal to k times x, where k is your variation constant. That's your variation constant. All right. So that's the variation. That means what? K is a number that will never change, right? So think of this equation when you see direct variation or see these types of phrases. Think of this equation to relate x and y, all right? Let's take a look at the second one. Inverse variation. Inverse variation, as you might guess also, is that the two variables move in opposite directions. Inverse variation, all right? You may see phrases like this. Y is inversely, I'm sorry, not y is inversely. How about let's start with y varies. Excuse me, sorry about that. Y varies inversely. The word inverse has to be in there. We'll look at the other one in a second. Y varies inversely as x. Okay. Y varies inversely as x. That's an L right there. Sorry about that. The sketchpad's giving me some grief here. But y varies inversely as x. Or you may see the phrase y is inversely proportional. That's what I want to write initially, but I want to make that second. Y is inversely proportional to x. All right, y is inversely proportional to x. So that means what? They move in opposite direction. That means as x goes up, y will go down. As x goes down, y goes up. So they go in opposite directions. Now the equation to relate that then is going to be similar to up here, except that it's not going to be k times x. It will be what? K divided by x. So y will be equal to k divided by x. And again, the k is the same thing. It's the variation constant. So k, it means the same thing here. This is a number that we have to figure out. All right. So how do we do problems like these using these two equations in terms of the concepts? Well, the key is what? The key is to figure out the right equation to use, and then you want to find k, and then you want to finish solving the problem. So let me go clear out. So I'll give you some guidelines here. Okay. Let's look at the guidelines on that. All right. So the guidelines for solving variation problems here for this section will be step 1 is to write the correct equation. So write we'll do some examples in a moment here. Write the variation equation. Which equation are we dealing with? Y equal to k times x or y equal to k divided by x, right? Depending on what kind of variation the problem is. So write the variation equation. All right, so step 1. Step 2, you want to use the initial information that's given in the problem and to find your variation constant. So step 2 is you want to use initial information, all right, to find k. So basically, step 2 is to find the variation constant, find the k, all right, and then step 3. You want to finish the problem. So finish solving the problem. And again, we'll do some examples to help you see that. Finish solving the problem. All right. So let's take a look at an example here. Okay. Let's take a look at this problem right here. All right. So take a look at this problem right here that I have for you. All right. So it says what? It says that the number of bushels of wheat, call that B, produced by a farm varies directly. So key is what? Direct variation here. I see the key words as the number of acres planted in wheat. Okay. So upon seeing the first sentence here, the number of bushels of wheat B produced by a farm varies directly as the number of acres A planted in wheat. Then let's write an equation that relates B and A. Well, direct variation, right? So this will be my y, this will be my x, basically, right? So the equation we're looking for is going to be b equal to what? Some constant k times what? Times a, the number of acres that we have planted in wheat. Okay. Now let's use the initial information. Here's the second part here. That will be so. Second part is to find k, right? So here it is. If a 25-acre farm yields 1,125 bushels of wheat, so let's use that initial information there to find my k. So we're told 25-acre farm, so A is equal to what? 25. All right. Yields what? 1,125 bushels of wheat. That's my B. So initially we're told that B is 1125, A is 25. So these are the initial values, if you will. So initial values, initial information. Initial values, if you will, right? So let's plug these two numbers in and solve for what? Solve for k here on the calculator, right? So 1125 is equal to 25 times k. So just divide by 25 to figure that out. All right. So k is equal to what? My variation constant. Well, 1125 on the calculator divided by 25. That's going to be 45. So k is equal to 45. Now, don't worry about the units until the final answer, right? Final answer has to be the right units, though. But k is just going to be a constant. Let's not worry about the units on k, all right? So, but k is 45. Now, let's rewrite this equation plugging in the 45 for k. So now this equation becomes what? B equal to what? 45 times a. Because that's what k is, right? 45. All right, 45 times a. All right, then. Let's finish off the problem, right? The question is what? What is the yield of a farm that has 220 acres of wheat? So again, 25 acres gives you 1,125 bushels of wheat. Now we have what? 220 acres of wheat. So my A, so we're solving the problem now, is what? 220, right? That's the acreage, right? 220. let's plug it in to get B. So that's not hard at all. So the number of bushels of wheat that we have is going to be 45 times the 220. All right, so final answer is going to be, punch the calculator, 9,900 bushels of wheat. So again, as acres go up, bushels of wheat goes up, right? They vary directly. As one goes up, so does the other. So 9,900 bushels of wheat. All right, so this is the solution we're looking for. Again, the key is what? First step, write the proper variation equation. Second step, use the initial information. In this case, 25 acre yields 1,125 bushels of wheat. So A is 25, B is 1125. That's the initial information. Plug it in to solve for K, which is 45, and then replace the K back into the original equation. So we get B is equal to 45A. And now we're told that what is the yield of a farm that has 220 acres of wheat. So A is now 220, and just plug it in to finish off the problem. All right, let's go and try another one. Let me go ahead and clear out this screen right here. All right, let me go ahead and clear out this screen right here. Let's try this problem right here. All right, let me go ahead and move in the right place there. All right. Okay, so let me go ahead and let's look at this problem here. All right, take a look at this example right here then. The illumination I produced by a light varies inversely as the square of the distance from the light. So that means what? Inverse variation right here, right? Keyword inverse in there. If the illumination produced 10 feet from a light is 12 lumens, find the illumination 2 feet from the light. All right. So as we get closer to the light, obviously the illumination should be brighter. The light should become brighter, right? Anyways, let's take a look at this problem, right? Let's write the equation for I and D, right? I varies inversely, I varies inversely as the square of the distance D. So the first step is going to be I equal to what? K divided by, right, inverse variation, but this time not just D, but what? The square of the distance D. So D squared. Make sure we see that, right? D squared. Okay? So that's the key equation to come up with. Hopefully you can see that here from reading the first sentence. All right? Anyways, let's look at the initial info. So initial info. Initial info here given will be what? If the illumination is produced 10 feet from a light is 12 lumens. So this 10 feet is what? Is that I or is that D? Well, 10 feet is the distance, right? So D is 10. D is equal to 10. And 12 lumens, that's going to be my I. That's the illumination, measured in terms of lumens. So I is going to be 12 in this case. All right? So let's plug these numbers in to this equation and find K once again. So let's do that. So 12 is equal to K divided by, what, 10 squared or 100 if you want to skip that step there. So this is K over 100. Right? So to solve for K, just times both sides by 100, obviously. So step 2 is to use the initial information to solve for K, right? So my K is equal to what? That's 100. 12 times 100 there, right? That's 12 right there. Sorry about that. All right? So that's going to be what? 1,200, right? So K is equal to 1,200. All right? So we have K. Now let's go ahead and plug it back into the original equation and finish the problem out. So now so this equation becomes what? Oops. I'm trying to get the sketchpad to work properly here. All right. So this equation becomes I equal to 1,200 there divided by D squared. All right. Can we see that? So I plugged the K in to the original equation. All right, so let's finish the problem. So it says, what? Find the illumination 2 feet from the light. So 2 feet, that's the distance, right? So D is now equal to 2. We can now plug it in to find I. So therefore, I is equal to 1,200 divided by 2 squared, or 4 if you will, right? So 1,200 over 4. So that's equal to what? 300. 300 lumens. The light gets more brighter. Oops. Okay, that's an L right there. Sorry about that. That's an L right there. So 300 lumens is the answer we're looking for, right? Bottom line, the answer is 300. Okay, so 300 is the solution we're looking for right here on this problem here. All right, let's go ahead and try another one here. Let me go ahead and clear out the screen, if you will, then. Let's go ahead and try another one. Let me go ahead and paste the problem here into the whiteboard. So there it is. All right. All right, let's take a look at this problem here. The electrical resistance R of a cable varies directly as its length L and inversely as the square of its diameter D. Excuse me. If a cable 16,000 feet long and 1/4 inch in diameter has a resistance of 3.2 ohms, what is the resistance of a cable that is 8,000 feet long and ½ inches in diameter? All right, so let's go ahead and look at the proper equation again. This time we have direct variation as well as inverse variation. Let's mix the two together. Now, we mix the two together, though, don't think there's going to be two K's, two variation constants. Just treat those two K's as just one K. Here's how you write that. So R is going to be equal to what? Varies directly as L, so K times L, all right, divided by, inversely, right, divided by what? Square of the diameter, D square. So this is the key equation to come up with, right? Varies directly as L, so K times L, inversely as the square of D over D squared, right? Now let's use the initial information again to find K. Once again, step 2 is to find K. All right, we're told that if a cable 16,000 feet long, so what is that? That is the length of the cable, right? L, that's L. So L is equal to 16,000. All right, 16,000. All right. What else? 1/4 inch in diameter. That's D. 1/4 or 0.25. You want to use a fraction for that. That's fine. All right. Let's plug that in to find K once again. Right. Actually, resistance is what? 3.2 ohms. So it has a resistance of 3.2 ohms. That's R. So sorry about that. I left off the R there. So 3.2. Sorry about that, guys. All right, can we see that? So L is 16,000, initial information, 1/4 inch in diameter, so that's D, and resistance 3.2 ohms, that's R. All right, so hopefully you can see that now. All right, let's plug these numbers in, these three numbers in to get K. So R is 3.2 equal to L is 16,000 times K, so 16,000 K divided by D squared, 1/4 squared, or 0.25 squared if you want to. All right, that's 1/4 right there. Sorry about that. Sketchpad giving me some trouble again, but 1/4 right here. Okay. All right, let's go and quickly solve this then. So let's simplify the 1/4, 0.25 squared. We want to use 0.25. 0.25 squared is going to be 0.0625. So this is going to be 0.0625 upon squaring down the calculator. All right. Then to solve for K, if you, I just times by the reciprocal of this fraction here. So let me simplify step, multiply both sides by 0.0625. There you go, 5 there, sorry about that, that's a 5. Over 16,000. Alright, 16,000. Okay, so it's the same thing to both sides. Alright, so 0.0625. Sketchpad is acting up a little bit. Sorry about that, guys. 16,000. All right. So, anyways, that cancels the 16,000 here, and the 0.0625. So K is equal to what? Sorry for the sloppiness here, but this is 0.0625 right here, guys. Sorry about that. Times 3.2 divided by 16,000. Punch on the calculator. So times 3.2. All right, and then divided by 16,000. All right, so K is going to be equal to, maybe better write that in scientific notation, but point what? 0, 4 zeros there. 1, 2, 5. All right. That's a big number there. I mean, it's a very small number, but too many zeros there. Maybe better to write it in scientific notation. So it's up to you how you want to go about it, but just punch in the calculator, bottom line. All right? That's okay. Let's plug it back into the original equation again. So my R is going to be what? R equal to, that's R right there. Sorry about that. Again, the sketch pad's acting up on me. So K is what? This big number, 0.0000125. That's a 1 right there. Times L divided by D squared. All right. Let's go ahead and plug in the values for L and D to finish this problem, because the question is what? What is the resistance of a cable that is 8,000 feet long? So L is going to be 8,000. So let's plug in L equal to 8,000. All right, and 1/2 inch in diameter, that's my D. 1/2, all right? So I'm just going to punch in the calculator. So take this number, times it by 8,000, divided by 1/2 squared, right? So then you're going to get 0.0000, all right, 125 times the 8,000. All right, divided by 1/2 is 0.5. I'm just going to write 0.5 just to make the writing simpler on the sketch pad, square. All right, I'm just going to punch it on the calculator to get that. All right, so that's number 0.0000125 times 8,000. All right, it's going to be 0.1 on top, divided by 0.5 squared. It's going to be 0.25 on the bottom. So that's going to be 0.1 divided by 0.25 equal to 0.4. So we're going to get 0.4 for the resistance, right? That's R. Right? So 0.4 what? Ohms. All right? So we get this solution here. In this case, we can mix the two variations into one problem, direct and inverse. But the key is to get the right equation, and then use the equation to find K initially. Once we get K, then we can plug it back into the original equation to finish off the problem here. All right, so now let me go ahead and give you some problems to solve and post into Blackboard. And let me go clear out the screen here. Let me paste it on here. So there we have it. Take a look at these three problems here, if you will. So number 1. A car uses 4 tanks of fuel to travel 1,800 miles. At this rate, how many tanks of fuel would be required for a trip of 3,000 miles? That's a proportions problem. But here are a couple of variation problems. The stopping distance S of a car varies directly as the square of its speed, V. If a car traveling 30 miles per hour requires 60 feet to stop, find the stopping distance for a car traveling at 45 miles per hour. So again, write the proper variation equation in terms of S and V. And then use the initial values here to find K, and then plug the K back in to finish the problem out. All right. Same thing on number 3. The current I in a wire varies directly as the voltage and inversely as the resistance. So we're mixing two variations together here. All right. If the current is 27.5 amps when the voltage is 110 volts and the resistance is 4 ohms, find the current when the voltage is 195 volts and the resistance is 12 ohms. Right. So again, same deal. Write the proper equation for variation. Use the initial values to find K, and then plug the K back in and finish the problem out with these last 2 bits of information. All right, so give it a shot. We'll go over it in class. Take care and have a great day.